Hey guys, so we're going to put some notes to the activity that we did yesterday. So transformations of functions. So you looked at a couple ways at how things shifted. Now at any point in time in this video, feel free to pause so that you can get the outline so you're not playing catch up, okay? And then just play it when you're ready. So first thing, transformations of functions. So we talked about the K shift, okay? So K, what happened if we had something outside of the parentheses? Well, you should have found that that affected whether the graph shifted up or down. Now, with it shifting up or down, it's shifting along the y-axis, which means it's affecting what variable? Y is always our dependent variable because it always depends on x. Okay, so then we went to where if something was in the parentheses. Now that was a little bit tricky. So outside of the parentheses shifted us up and down, but inside of the parentheses, well, that shifted us left and right, but there was something kind of odd about it. So it's our horizontal shift, but you might have noticed when you had like a +3, well, you would think it would go right, but instead it went left. And if you had like a -5, again, you would think it would go left, but instead it went right. Now notice how this function, how it has a minus h. Well, that minus can also be read opposite. It's the opposite of what you would think. So it's the opposite of the horizontal shift. So if it says x +3, well, you got to head left. If it says x -2, well, we got to head right 2 units. So that horizontal shift is always opposite. Now the horizontal, that affects our x-axis. So since it's affecting the x, it is affecting the independent variable. All right. Now something we didn't get into was a. If we had a number out front, so that affects the width of our parabola. Well, now this time we're doing parabola. You can see that because it's a squared. But it doesn't necessarily have to be. We can use it for something that's linear, cubic. We can use a funky cube root graph. And yeah, I'll show you those later. They can be used for all of them. If they're in this format, it all shifts the same. So that's kind of nice. So again, A describes our width. Now, if A is greater than 1, whoops. So if we have a positive a and it's greater than 1, so think like 2 or 3, what that tells me is my function is growing, say it's 2, twice as fast as normal. Or if it's 3, 3 times as fast as normal. So anything greater than 1, it gives us a vertical stretch. It makes the function skinnier, all right? Whereas if we have an a that's between 0 and 1, so a fraction, like say 1/2, 1/3, 1/4, well, it tells us that it's growing half as fast or a third as fast. So that graph is going to be a little bit wider because it's not growing as fast. That's called a vertical shrink. So a vertical stretch, that makes it a more narrow graph because it's growing super fast. Whereas if it's between 0 and 1, so a fraction, it's a vertical shrink. Now if a happens to be negative, well, that just literally flips your whole function. So if it was positive and facing up, well, now it's going to face down. And it vice versa. If it's facing down, well, it'll flip up. So how do we know whether the dependent or independent variables are affected? Well, is it having a horizontal shift? Is it affecting the x-axis? Or has it got a vertical shift? Is it affecting the y-axis? Now this graph, this looks a little new. That's okay. Don't freak out on me. So it says the graph of a of x is shown. Let b of x equal a of x +2 cubed minus 5. This is a cubic function. It's got that S kind of shape to it. And it wants us to graph b of x. Well, first, what do those shifts tell us? What does -5 mean? Well, hopefully you told me minus 5. Since it's on the outside, it means to move down 5 units. And that plus 2, well, that's a horizontal shift, but what's key about horizontal shifts? Always opposite. So plus 2, instead of going right, we need to head left 2. Now with this function, it looks a little weird. So what I want you to do is pick one nice point. Hopefully you're like me and I'm like, ooh, look at that origin. That's so pretty. So I'm going to start there and I'm going to shift down 5 units. Well, look, my y-axis is numbered by 5s and left 2. 1, 2. Okay, now find yourself another point. So I'm going to take this one right here. That way it'll be, you know, along the same playing field. So we're going to go down 5, left 2. All right, I've got this little piece right here. So it's kind of in between 1 and 2. I'm just sketching. This does not have to be perfect. So I'm going to move it down 5. I think it's a little bit above negative 5. So I'm going to go a little bit above negative 10 and left 2, which is going to leave me a little bit to the right of negative 1. So all I'm doing is sketching my function. So how far up should we go? Well, remember, we're shifting the whole thing down. So I'm just going to stop right there. Now, if I were to keep going, it would come back and finish the shape. Does that look familiar? Just shifted down 5 and left 2. So if you're ever questioning yourself like that, like if it's moving off the graph, just continue it to see, does it look familiar? Which this absolutely does. Now it says, what would happen to our function if we multiplied a by negative 2? Well, let's come back to that after we see how we're transforming given the tables and see if you can figure that out a little bit better. Okay, so I'm going to zoom out so you can set up the notes. So go ahead and pause this and then start when you're ready. Okay, so the first one says the given table represents a function. So we have the function f of x. Now remember, f of x is just a fancy way of writing y. So if you're ever getting confused, just replace the f of x with y. All right, so we have our first function. Got a lot of input and output values. It's looking a little weird. So I don't know. We'll see if you can figure that out, what type of function that is. If not now, you definitely will be able to later. So the second part says create a table demonstrating g of x. Now, where g of x is a third of f of x. Okay. Remember, a third of f of x, I can replace that and say, well, it's a third of my y values. So see how all of my x values are the same? That's actually super helpful. So I can just take this and plug in, pick a new color, 1/3 of, well, when x is negative 2, what's my y? Negative 8. So 1/3 of negative 8. Oh, well, that doesn't go in nicely. That's okay. I'm just going to do negative 8/3. You do not need to change this to a decimal. You can leave it as an improper. That's totally fine. If you wanted a graph, you would probably want to change to a decimal just to make it a little bit easier to figure out where it is. So this next one, again, a third of y. Well, when x equals negative 1, y is negative 3. So a third of negative 3, well, negative 3 divided by 3, negative 1. So if you think you got it, go ahead and pause the video, try the next ones, and then come back and see how you do. Okay, so I'm going to keep going. A third of, well, when x is 0, y is, 0. That's easy. Third is 0, 0. So the next one, a third of, when x is 1, y is 3. So a third of 3, 1. Awesome. The next one, 1/3 of, well, when f of x is 2, y is 8. So a third of 8. Brings me back to 8/3. Okay, this is a funky little function. We haven't talked much about these yet. But you know, we'll get to some weird ones. So hopefully that was okay. A lot of these, it's not so much the arithmetic, it's being able to read the table, figure out what they're asking. All right, now let's look. This next one, this is a little bit more difficult. So if you were having trouble on the back of the worksheet from yesterday, you might be able to have a little bit easier time after watching this. So if so, make sure those are done because you'll be turning those in tomorrow in class. All right, so this next one, we have f of 2x. F of 2x. Well, x is equal to -1. So that tells me, and then -3. So f of -2. Well, what's f of -2? Well, to know that, we need to go back to the original function and find what's f of -2. Well, -8. So I have -8 minus 3, and I get -11. Let me go back over that in case I lost you. To me, these are a little bit more confusing. So f of 2 times x, x is -1, so f of -2, we got to go back to the original function. F of -2 is -8, so then I just plug in -8 minus 3, and I get -11. All right, so let's try the next one. F of 2 times -1/2 minus 3. So 2 times -1/2, -1. So I'm going to come back to my original. F of -1 is -3. So I have -3 minus 3. Keep, change, -6. Beautiful. If you think you got this, pause the video, try a couple on your own, see if you can figure them out. All right, I'm going to continue. So f of 2 times 0 minus 3. So f of 2 times 0 gives me f of 0, which is 0. Awesome. So 0 minus 3, -3. Sweet. All right. F of 2 times 1/2. 2 times 1/2 is 1. So f of 1, I come back here. F of 1 is 3. Oh, let me finish writing that. So 3 minus 3. Keep, change, 0. All right, last one. Finish strong. F of 2 times 1, minus 3. So f of 2, come back over here. F of 2 is 8. 8 minus 3, that's easy. 8 minus 3, 5. So there's my new outputs for my h of x function. So when it says, what would happen to our function if we multiplied a of x by -2? So think about that first example where we had 1/3 times f of x. Well, it made our outputs shrink. So if we multiplied a of x by -2, what would that do? Well, it should make our outputs grow. So it would make our outputs larger. Well, not necessarily. It would make them larger and it would make them flip because of the negative. So that gives you a couple things to think about. All right, well, I hope you enjoyed this. Hope it wasn't too awful. Come to class with questions tomorrow and I'll be happy to answer. Have a great day, guys.